So on the workbench today, I have the NanoVNA-F. This is a very inexpensive and also very small, as the name implies, piece of test equipment that you can use, that I'm going to use to measure my antenna's SWR. There's a lot more that you can do with it, but I have to admit I'm an absolute beginner, except for a little bit of practicing that I did before I started recording the video. I do give credit to someone named Martin Svaco, who has a call sign NA2JK, who wrote the Absolute Beginner's Guide to NanoVNA and shared it in the NanoVNA Groups IO. So definitely big shout out to him and a recommendation if you're new to the NanoVNA and need someone to walk you through step by step. So, as I mentioned earlier, my intent with this device was to measure a 40-meter dipole antenna that I constructed about a year and a half ago, and I haven't done any tests on that. So it'll be interesting to see how that antenna performs and the characteristics of that antenna using even this simple and inexpensive piece of test equipment. I will say this is not a comprehensive guide to setting the device up out of the box. Martin's documentation walks you through that from the very beginning, because if my device is any indication, the device doesn't come with any sort of documentation in the package, so you're kind of up to finding it online or just trying to figure it out on your own, which unless you've looked at the source code, I don't know if you could effectively figure it out on your own. It's not necessarily intuitive. The first thing that I need to do to set this up to measure my 40-meter dipole is to set up the frequency range for the 40-meter band, the amateur 40-meter band. So that's in this menu called Stimulus. So if we go, let me go back out to the front. So this is this wheel at the top, which rocks back and forth and presses in, is so far my favorite way to use the device. So you press that in to bring up the menu, and then you press it, you rock it back and forth to scroll through the menu. And I'm going to press it to set the stimulus. And I'm going to start at 7 megahertz. So that's the bottom of the 40-meter band. And we can see the start change to 7 megahertz. And I'm going to move the stop. I think I want to do 70 or 7.3 megahertz. So after setting the frequency boundaries from 7 megahertz to 7.3 megahertz, it might be helpful to review the traces or the plots that the device will show. So you can see the plots that I've currently selected labeled here at the top: channel 0 log mag, channel 0 Smith, channel 0 SWR. The device can show one more trace or one more plot, but I'm only showing 3 right now. To change these plots to show less or show more or show different data, you can open up the menu, go to Display, and go to Trace to toggle the traces on and off. So if I toggle trace 0 off, I highlight trace 0, and then I press it, and the whole screen sort of adjusts around just what was in trace 1 and trace 2. If I want to edit what's in trace 0, I make sure that trace 0 is the active trace, and you can tell that it's active because of the way it's highlighted in its color. If we go back out of the menu, I think I can There are different ways to select the active trace. I think you can tap on the plot itself. Yeah, so I just tapped on the marker that I could see on the Smith chart, and now you can see that the Smith chart trace is highlighted. If I tap back on the yellow log mag plot, I might be able to select it again. Might have to tap on the marker itself. Yeah, I think I have to tap on the markers to change the selection. If you're not having any luck with this, I think a surefire way to do it is through the display menu and just toggle a trace on and off. So if I wanted to select trace 1, I can just go in there and choose it. Or in trace 2, I can choose that and press it again to toggle it off, and press it again to toggle it back on. So if I wanted to change the Smith chart there to be something else, I can use I can make sure that that chart is selected, which it already is based on me going in here and toggling trace 2 most recently. Then I can change what's displayed on that chart by going to Format. And I can just choose whether I want to show log mag, phase, delay, the Smith chart, which is what it is currently, SWR, polar, linear, real, imaginary, resistance, reactance. So if I change to resistance, I choose resistance and I just press down, and I see that the label for that trace goes to R, and the scale is 100. And the current measurement is, bouncing all over the place because there's nothing actually connected. So if I wanted to go back if I wanted to go back to the SWR, I selected more to go to this longer list of options. I can select back and go choose SWR. Oh, that was not what I was supposed to choose. I was supposed to choose Smith charts. And then it brings the coordinate system for the Smith chart. So now that we've chosen the plots that we want to look at, log, mag, Smith, SWR, and we've set the boundaries, the next thing is to go in and actually calibrate the device for that frequency range. So I'm scrolling through Martin's documentation right now, and I'm going to go to the section called calibration. And the every one of these NanoVNA devices comes with a set of calibration standards, and there are 3 that I've set above the device there. The first one, the one that I'm lifting up now, is open. It's the one that's commonly referred to as open in the instructions. And if you look inside, you can see that there's no pin. Like if we were expecting this to be a coaxial connector or an SMA, an SMA connector, we expect there to be a pin in the middle. This is just a hole. So this is an open circuit standard. This next one is the opposite of an open circuit. It's a closed circuit or a short. So that pin that you see in the middle there is connected to the outside of the connector and should provide no resistance. And the last standard is the one that looks a little bit different from the outside because it seems to be, it's 2 pieces, and it's a little bit longer. This is a 50 ohm standard, so it's kind of in between, electrically speaking, the open circuit, which is nominally
infinite resistance, the closed circuit, which is nominally 0 resistance, and then 50 ohms is a pretty standard resistance that we would use in amateur radio. So we use those and we connect those to these ports. I'm actually not connecting them directly to the ports. I'm connecting them to little pigtails that came with my device. So I'm going to go back to the top menu, and there's this option called Cal, or it's going to open the calibration menu. And the first thing to do is to go through and reset whatever calibration is already there. And you can see those lines change, and you can see the Smith chart change in the background. I'm going to go ahead and press reset again, and I found that it's just a habit of mine to make sure that things have completely are reset. Now, the first thing that we'll do is we're going to, now that we've reset the current calibration, we're going to go to Calibrate at the top of that Cal menu, and we're going to go through each one of these: open, short, load. I guess the fourth option is isolation, and then through. And I'll be following along in Martin's documentation. So open is pretty self-explanatory. We're going to use the open circuit standard here, the one that does not have a pin, the only one that doesn't have a pin. And in order to connect it to those pigtails, I have to use this female-to-female SMA barrel connector. So I'm just going to put my open circuit standard onto that female-to-female barrel connector, snug it but not over tighten, and then connect that onto the channel 0 pigtail and snug it but not over tighten. So I've done that, and with the open item highlighted, I'm going to depress that, and when the open is highlighted in black on the menu there, you know that that calibration has been registered. Now I'm going to take that open standard off, set it aside, and the next thing is short. So I'm going to use the standard with the pin in the middle, but aptly named, is a little bit shorter, and just a one-piece short circuit of these two connections. Snug it up, and you can see that some of the lines have moved here. Some of the, not lines, I should say, the markers have moved on the Smith chart, and I'm going to set that as the short. Then I'm going to put the load on, the load standard on, and the load is the two-piece standard, which has a pin. Put that on the barrel connector, snug, and then select load. The rocker is a little bit finicky, so I might find myself using the touchscreen as time goes on. Then all of those calibration steps took place on channel 0 here, the port on the top, and this is really the port that's going to get the most use for me testing a device like an antenna. You would need both ports. You would connect a filter across both ports. So this is like the transmission port, and then this is the reception port, or the receiver. So you can measure the amount of reflected radio frequency energy that comes back into channel 0, and that's really the SWR measurement that I'm looking for. But if you were measuring a filter, and some of that energy might be reflected,
and other energy might be passed through, that's why you would connect a filter to both of these, because this channel 0 would be sending some RF energy through the filter. Some of that RF energy would be passing through the filter, would be passed by the filter, and would go back into the device to be measured, but other energy would be reflected or blocked by the filter, and it would go back in, and the device is going to measure that as well. So that's how you see these S11 and S21 parameters. Those are standard parameters that you would use to characterize a filter or another device that could work like a filter. There's also some more diagrams on the back of the device which help you remember that. So you see the reflection is coming back from the TX, those ports. We're looking at the device in reverse now. So those ports, channel 0 is on the bottom and channel 1 is on the top. So transmit comes out of here, TX, and the reception, RX, comes out through there. I'm going to flip the device back over, and you can see how that is oriented. So I think I actually closed that calibration. Nope, it's still there. So let's go and do the isolation calibration, which I'll be honest, I don't really know what isolation means or why it's called isolation. But I do know, thanks to Martin's documentation, that the way we calibrate it is by connecting the 50 ohm standard, which you're familiar with, to channel 1, which is the RX port right here, channel 1. So I've got the pigtail for the RX port, and I'm going to move my female barrel adapter onto that pigtail, and then connect the 50 ohm load standard to that. I'm going to hit isolation, and then the last thing is through, which is, I think, a little bit more self-explanatory than isolation. Basically what we're going to do is we're going to connect both pigtails together, and by, as such, we're going to connect both ports together, and we're going to measure basically port to port. So you can see as I'm connecting the ends of those pigtails together with that barrel connector, the plots on the screen were going a little crazy. Now that they're connected and snugged up, I'm going to tap through. Maybe I have to do it twice. And now that all of these items have been set, I can tap done. And I have to save that calibration in one place. I'm going to choose memory 0, because that's the kind of the standard memory that's loaded whenever the device is turned on. You can have 4 other memories to switch to recall. So that's been saved, and we can see over here C0, we're using calibration 0. And I don't know what the DRSTX stands for, but according to Martin's documentation, he says that means that the device has been calibrated and is using the calibration settings. So trust Martin on that one. So I'm going to disconnect these pigtails and take off that barrel adapter, and I should be ready to go and test my antenna now. The device has been charging over USB, and I can see that the battery light is still flashing. The battery LED is marked on the back panel. And flashing means that it's charging, but I think that we'll be good to go and use it for a little bit at the antenna feed point. My HF antenna obviously doesn't use an SMA connector, so I purchased a set of adapters, and I plan to use this this SO239 to female SMA adapter at the antenna. So ideally, I would have had calibration standards to calibrate with this connector, but I don't. So I'm just going to assume that this is part of the character of the antenna, this adapter, and it's going to, whatever effect it has on the measurement will be part of the measurement. So we're outside at my antenna's feed point now, and I'm going to connect the adapter from SMA to SO239 to my antenna's feed line, which is actually pretty heavy-duty LMR 400. So I'm going to be careful working with two very different sized components here. Make sure I'm not going to cross-thread anything. Make sure that I'm getting a good connection. Okay, I think that's snugged up. And now let's take a look. So here we go. So it looks like at the top, man, this is a little bit what I expected, actually. I knew that close to, remember the top of our scale there, I'm going to let go of this, is 7,300 megahertz, not 7,300 megahertz. Remember that the top of our scale is 7.3 megahertz, and the bottom was 7. You can see here with our marker on the SWR plot that looks almost linear going up, that that SWR up there is 4.7, 4.8. So not very good SWR. But as we go down to 7180, that's where we cross over from 4 to 3. And as we go lower, closer to the bottom of the band, we're getting closer to 3. Man, so the SWR is higher than I thought. And seeing the trend of that SWR plot, I know that it's a little bit too long. The bottom, the lowest frequency that I can measure here is 7 megahertz, and it's evident that the SWR plot is still trending down. So that's good news for being able to modify the antenna, because I know I can still I can trim, I can shorten that antenna. If the antenna was already too short, it'd be pretty difficult to make it longer. What I did expect that the antenna was a little long. I knew that as I got closer to 7,200, 7,300 megahertz, not 7,200, 7,300, but so 7.2 megahertz, that the SWR was usually going up. I just didn't expect it to be this high. But obviously the tuner in my radio is making up for that. So I will say the log mag plot, which is something that I wanted to learn about, something that I wanted to see in comparison to the other plots. It's still a little bit unclear to me. I can see that on a scale of 10 dB, log mag is at negative 6 dB right now. So I guess maybe that's the return based on what the device is sending. So how much energy is being reflected from the reference that's being sent. Let's do another sweep through, starting from the bottom. So it's 7 megahertz, 2.75 SWR. It's about FT8. 7075. About just over 3.3. And then normally where I do a lot of listening and there's always a lot of activity is around 7.2. So we're right at 4 SWR. And then as we go to the top of the band, I knew this was getting outside of the antenna's tuning range, but you can tell it's getting close to 5. Well, so it seems the device works. It seems that it's gives me a nice characterization of this antenna. I know that I definitely need to make it shorter, and I can use some of the information that I've collected here to make an estimate of how much shorter. I can go in and do some research on the in the antenna handbook and make some of those changes and get even better performance out of this antenna without requiring so much tuning.